Here I discuss the instruction set of 8086 microprocessor. 8086 microprocessor suffers 8 type of instruction, that data transfer instruction, arithmetic instruction, bit multiplication instruction, string instruction, program execution transfer instruction, processor control instruction, iteration control instruction, interrupt instruction. So first I know that what is the instruction set. What is instruction? An instruction is a binary pattern designed inside a microprocessor to perform a specific function. The entry of instruction that is microprocessor suffers is called the instruction set. 8086 has more than 20,000 instructions. Also note that this is the classification of instruction set. There's another two. There is a data, arithmetic, bit multiplication instruction, program execution transfer instruction, string instruction, processor control instruction. Another two is the iteration control instruction and interrupt instruction. This first one is the data transfer instruction. This instruction are used to transfer the data from source to destination. Source operand to the destination operand. Following the list of that operand can be constant, memory location, register IO port address. And what is the first example of data transfer instruction? Then move destination to the source. DES for the destination. Then we register or memory operand, and SRC, that is the source. This operand can be register, memory location, or immediate operand. Cannot be memory location at the same time. CX, 037AX, that is AL, BL. BX, 0301H, that's the example of move. This is used to copy the byte of word from the provided source to the provided destination. Next is the push, used to put a word at the top of the stack. The operand into the top of the stack, that is push BX. Pop destination, that is it pops the operand from the top of the stack to the destination. Can be general purpose register, segment register, or memory location. This pop AX. Next is the data exchange. It's an instruction that is to exchange the source with destination. That is that cannot be exchanged to memory location directly. Exchange DX, AX. We can use the exchange as an opcode in the 8085 microprocessor, but in the 8086 microprocessor, exchange destination, source. That means it cannot be exchange the source with destination, but it cannot be exchanged to memory location directly. Next is the IN, this in. It's used to read a byte or word from the provided port to the accumulator. That is, transfer the operand from specified port to the accumulator register. In AX, 008H, 28H. That is the example of in accumulator, port address. Out used to send one byte or word from the accumulator to the provided port. That means it transfer the operand from the accumulator to the specified port. Out 002H, 28H, AX. That is transfer the operand from the accumulator to the specified port. Next, LEA, that's instruction to transfer the address. LEA, register, source, is loads 16-bit register with the offset address of the data specified by the source. LEA, BX, DI. This instruction loads the content of the DI into the BX register. LEA, that's used to load the address of the operand. Load the address of the operand into the provided register. DI, that is the destination index. That is the address of the operand, that is the load in the provided register in the BX register. Next is the LDS, that is destination, source. That LDS is the load the DS register DS register, data segment register, and other provided register from the memory. It loads 32-bit pointer from the memory source to the destination register and DS. Destination register and DS. The offset is placed in the destination register and the segment is placed in the DS. That is the LDS BX, 0301H. The word at the lower memory address must contain the offset and the word at the higher address must contain the segment. মানে lower order address টা কি contain করছে, lower memory address must contain the offset and other word at the higher address must contain the segment. Next is the LES, destination comma source. Destination use the load the ES register and other provided register from the memory. 32-bit pointer from the memory source to the destination register and ES extra segment. The offset is placed in the destination register and segment is placed in the extra segment register. The instruction is very similar to the LDS except that is initialize ES instead of DS. This is the LES BX, 010301H. Next, LAHF, that copies the lower byte of the flat register to AH register. Lower byte of the flat register. SAHF used to store AH register to the low byte of the flat register. Content of the AH to the lower byte of the flat register. Flat register to the top of the stack. Push F. Pop F of the stack top of the flat register. Next is the arithmetic instruction. These instructions are used to perform arithmetic operation like addition, subtraction, multiplication, division, etc. Following, this the first one is the add destination comma source. It adds a byte to byte or word to word. That means used to add the provided byte to the byte. AF, CF, OF, PF, SF, ZF flags at AL, 74H, at AL, 74H. That is the example of add destination, source. Destination, that is the AL is the destination and source is the 74H. ADC, it adds two operands with CF register with carry flag, that's AL, 74H, DX, AX, ADC, DX, AX. That is the used to add with carry. Next, subtraction, byte from byte or word from word. Subtraction, CF acts as a borrow flag. CF acts as a borrow flag. Sub AL, 74H, sub DX, AX. Next is a SBB. SBB means used to perform subtraction with borrow. Used to perform subtraction with borrow. This SBB AL, 74H, SBB DX, AX. That is the example of this arithmetic instruction. Next the INC source. What is that INC? Increments the byte or word by 1. INC, that means increment the byte or word by 1. The operand can be register or memory location. It affects all the flag, the AF, OF, PF. See, PF, that is a parity flag. ZF, 0 flags. CF is not affected. INC, AX. INC means increment the AX register by 1. DEC, source, decrements the byte or word by 1. That is the operand can be register or memory location. CF is not affected. That is a carry flag is not affected. DEC means DEC, decrement the AX register by 1. That is the DEC AX. Next, arithmetic instruction, AAA. Adjust the X key after addition. The data entered from the terminal is the X key format. This instruction does not have any operand. This instruction allows to add the ASCII codes. ASCII adjust after addition. After addition, it adjusts the ASCII value. Other ASCII instruction, that is the AAS, ASCII adjust after subtraction, AM, ASCII adjust after multiplication, AAD, ASCII adjust after division. Next, DAA, decimal adjust after addition. It is used to make sure that is used to adjust the decimal after addition or subtraction operation. Decimal adjust after addition or subtraction. After subtraction, that means DAS, decimal adjust after subtraction. The result of the adding two BCD numbers is adjusted to be current BCD number. It only works on AL register, but DS only works on the AL register. Next is the NEG, source. NEG. What do you mean by NEG? It creates 2's complement of a given number. That means it changes the sign of a number. CMP compare to provided, compares to specified var, that source and destination as constant, register or memory location. Cannot be a memory location at the same time. So the comparison is done simply by the internally subtracting the source from the destination. Source from the destination comparison is done simply by the internally. The value of the source and destination does not change, but the flags is modified to indicate the result. Next is the arithmetic instruction. This multiplication sources can be, that is used to multiply unsigned byte by byte. We all know that signed multiplication instruction, that is the IMEL, source. That is, it is an unsigned multiplication instruction, 2 bytes to produce a word or 2 words to produce a double word. AL into source, DX is that AX equal to AX into source. This instruction assumes that one of the operand in AL or AX can be registered or memory location. IMEL means signed multiplication instruction. Division, that is unsigned division instruction, DIV, source is divides word by byte, or double word by word. The operand is stored in the H divisor SRC is, and the result is stored as AH is the remainder, AL is the quotient. IDIV source, that is since the signed division instruction. CBW used to fill the upper byte of the word with copies of the sign bit of the lower byte. Converts the byte AL to word in AX. Converts the byte in AL to word in AX. The conversion is done by the extending the sign bit of AL through AH. Its conversion is done by extending the sign bit of AL through AH. CWD, that's convert word to the double word. Converts word AX to double word in DX. The word, convert the word, used to fill the upper word of the double word with the sign bit of the lower word. Convert the words. It's done by extending the sign bit of AX through DX. Instruction converts the word in AX to double word in DX. Next is the bit multiplication instruction. These instructions are used to perform the operation where data bits are involved. That is the operation like logical, shift, etc. There is the testing. This instruction can be used for testing a 0-bit, set or reset bit, shift bit across register. NOT, not. This complements each bit of source to produce one's first complement of the specific operand, registered or memory location. AND operation, that is the AND operation of destination and source, can be immediate number, register or memory location, destination be register and memory location. Cannot be memory location is the very, very important point. Both operands cannot be memory location at the same time. Becomes 0 after operation. CF and OF become 0 after operation. used to add in each bit or byte with the corresponding bit another byte. That is, the performs the AND operation. OR operation performs the OR operation to the destination and the source. Immediate number registered or memory location. Destination can be registered or memory location, but both operands cannot be memory location at the same time. JOR operation. This JOR destination is the same as AND and OR operation. Bit multiplication is SHL destination comma count. It receives bits of byte or word left by count. 0 in LSB. MSB shifted into the carry flag. That is the SHL. SHL, that is the used to shift the bits towards the left and put 0 in the LSB. And MSB shifted. SHL is used to shift bits of a byte towards the right or put 0 in the MSB. This opposite, the LSB shifted into the carry flag. Next is the ROL. This rotates bits of bytes or word left by count. MSB is transferred to the LSB also in the to the CF. So RO1 is used to rotate the bits or bytes towards the right. LSB and MSB carry flag. MSB transferred to the MSB also to carry flag. MSB and to carry flag. This also the 3-bit manipulation. There is a 3 instruction. The data transfer instruction, arithmetic is a bit multiplication instruction discussed in this lecture. In the next lecture, we can discuss string instruction, program execution transfer instruction, process control instruction, iteration control instruction, interrupt instruction. Thank you.